and welcome back to another mathematics episode. Today we want to talk about the t-test, which is a statistical hypothesis test to assess if differences between groups are significant. Now, the full name is actually student's t-test, so this is usually the t-test one refers to, but there are other types and we'll talk about it in a minute. So, the general principle is that you want to compare the means of two data sets. First, you have to define your so-called null and alternative hypothesis. H0 equals to the hypothesis that the difference between the mean values between those two groups is 0, while H1 means that the difference is not 0. As soon as you have defined those, you can calculate the t-value by using this formula, and I know this looks really complex, but the graph depicts the general principle. So you have two mean values and you want to determine if those mean values are different enough to say that those are actually two subgroups. Now, according to the t-value, you can either accept or reject the null hypothesis. In general, if you have a large t-value, this usually corresponds to a more substantial difference between the groups than a smaller one. So there are different types of t-tests which you want to apply according to your research question and also to the structure of your data set. The tests can be either one or two sample ones or also paired. So, as the name suggests, one sample means that a group is compared to a specific value, for example a threshold, which you see depicted on the left side here by the blue line. And essentially paired tests are the same, but usually here we're making two measurements for the same person. Now for two sample ones, we compare two independent groups. This is what you see here depicted by the red and the blue graph. Then there are one and two tail tests. If we have a one-tailed test, it's only of interest if the mean is bigger or smaller than a specific value, which you can see here, but not both. And for two-tailed tests, it's relevant whether there is any difference. And here you see the mathematical formula depicting it. Now, we use t-tests to compare the means of two data sets. But if we're talking about multiple groups, there is the so-called ANOVA or also other statistical tests. T-tests are parametric ones, which means that they have the same assumptions as for the normal distribution. If you're not completely familiar with normal distribution, there's a separate video about that linked above. Now, to revise, the data has to be independent, follow a normal distribution, at least more or less, and that the variance between the groups is similar. If your data does not meet those assumptions, you can perform alternative tests like the Wilcoxon rank test. And as indicated before, apart from the student's t-test, there is also the variance t-test. So the assumptions here concerning the variance are not so strict. And here, just to show you what you might get, if you have a t-value and you know your significance level, so your alpha level, which can be 0.05, and you know the degrees of freedom, so if you have 6 variables, your degrees of freedom are 5, you always have n minus 1, then you need a t-value above 2.571 to have a significant result. Now, we're talking about the t-test as there are so many applications throughout science, because it's often of interest to ascertain if there are differences or if something is superior to something else. For example, when you're testing a new drug. There you might want to compare life expectancies or also just the duration of the disease to assess if one medication is better than the other one. You can also search for differences within one person, for example, if someone starts training or if they start taking another medication. Yes, now, this was the basis and you can calculate those things by hand to a certain extent, but usually statistical softwares perform those t-tests, and they also compute p-values. Usually in science, a p-value of 0.05 is said to be statistically significant. And if your p-value is smaller than that, you can reject the null hypothesis, meaning that there is a true difference between your groups. Those were the very basics for t-tests to give you an introduction into this highly complex. There's, of course, a lot of mathematical background needed to understand this topic fully, but I hope this was a quick and still informative introduction. If you liked this video, don't forget to give it a thumbs up and to subscribe to the channel to see weekly uploads on highly relevant scientific topics.